welcome to my channel. So after a long time, okay. So today we will discuss another important topic, that is BLU estimates and Gauss Markov model. So BLU estimates and best linear unbiased estimates and the use of Gauss Markov theorem in explaining these BLU estimates. Now we must always remember the assumptions of BLU estimates, that its mean is 0 and variance is constant. So we should always remember this. Now the general assumptions in matrix, so when we discuss linear algebra, we discuss in details that suppose the model is yi is equal to alpha plus beta xi plus ui for n number of observations. Alpha is the intercept and beta is the coefficient or regression coefficient. So what are those assumptions we discuss? That expected ui is equal to 0, that is mean of the error term. Mean of the error term is 0 for all I, and the variance and covariance expected ui uj. So in matrix form, if we remember that the diagonal elements and off diagonal elements, so the off diagonal elements should be 0 for I not equal to j. That means columns are not equal to the rows, and when I and j ranges from 1 to up to n, and the diagonal elements are sigma u squared. That means it is variance, so constant. So it is called the homoscedastic, means off diagonals are 0 and the diagonal elements are constant. So we assume this. Now the theorem says that estimates must be linear and unbiased. The estimates should be linear and unbiased. Then secondly, OLS estimators have lowest variance. So what estimators will get, whether it is the intercept alpha or beta, so OLS estimators have lowest variance. Okay, so it is linear, unbiased, and the smallest or lowest variance. Now, property of linearity. That beta naught, estimated beta naught, is the function of y. This is dependent variable. So this is the intercept. Estimated intercept is the function of y. So its value will depend upon the values of y. So similarly, regression coefficient, estimated regression coefficient, is the function of y. Now, beta naught estimated and beta 1 estimated, is the intercept and the coefficient, regression coefficients, are linear functions of the observed sample values yi. As I said, it is the function of y. So y is the function of x, and the model or the functions will have, it must have the highest power must be 1. That means with power 1. Only then it will be linear. So here it is linear because highest power of x is 1. So it is linear. Then, as I said, that beta naught, and that means intercept, and the regression coefficients are functions of y. So beta 1 estimated, we got earlier that beta 1 estimated is equal to sum xi by sum xi square into yi. So we have already derived this in other lectures. So is equal to summation ki yi when ki is equal to xi by summation xi square. So if we put this as ki, so beta 1 is nothing but ki yi. Okay. Values of x are set of fixed numbers. K's are fixed constants from sample to sample. So regarded as constant weights to y. Now beta 1 estimated is equal to sum ki yi. Okay, sum ki yi, as you say that sum ki yi. And what is this? That k1 y1 plus k2 y2 plus so on plus kn yn. This means it is, if we sum, if we add this, then it will sum ki yi. So this is the function of y. So the values of beta 1 in the regression coefficient will depend upon the values of y. Then beta 1 estimated is a linear function of y's, and beta naught estimated depends on the values of y and is a linear function of y. So beta naught estimated, we have already got earlier that sum 1 by n minus x bar ki into yi. So we have already derived this in the earlier lectures, and x bar ki are fixed constants. So there is a little hint that we have got estimated beta naught, that means intercept, is equal to y bar, that means average of y minus estimated regression coefficient multiplied by the average of x. Now this can be expressed as this. Now then similarly estimated beta 1, that means the regression coefficient, is equal to summation ki yi. We have got it. Now how to express this as this? Now beta naught is equal to y bar minus x bar summation ki yi. That means we can put the value of the beta 1 estimated here. It is we have got earlier the summation x by summation x square, that this is ky into yi. Now y bar, the average of this is summation y by n minus x bar into ky yi. So if we take out yi, that means from here, or we take yi common, then it is summation 1 by n minus x bar summation ki into yi. So if we remove the bracket, it will be this. So beta naught, we can express beta naught as this instead of y bar minus beta 1 estimated x bar. We can express this. Now unbiasedness. What are the important properties of unbiasedness? Is that expected beta naught, estimated beta naught of the intercept should be equal to the population or true beta naught, true beta. Okay. Similarly, the regression coefficient, estimated regression coefficient should be equal to the true beta. So this means that with the increase in number of samples, so when sample size is increased, then value of the estimated parameters will converge to the true value of the parameter. So these are the true values of the parameters. So with the increase in number of samples, so this will be equal. So this so when it will be equal, then we say these parameters are unbiased. So you can write with the increase in sample size. With the increase in sample size, estimates will converge to true value of the parameters. Okay, so with increase in sample size, estimates will converge to true value of the parameters. Then it is unbiased. Okay, and thank you very much for watching. Go on watching and please share. So in the next class, next discussion we'll have on the Gauss Markov theorem and variance. Okay, thank you very much.